All right, so today we're going to talk about the vertex of a parabola specifically. And the vertex of a parabola is always either the highest point or the lowest point on it. So the graph, if it opens up, in other words, if A is positive, then the vertex is going to be the lowest point. And if A is negative, so it opens down, then the vertex would be the highest point on them. And yesterday we mentioned vertex form. And so we're going to talk about vertex form again today and talk about where or how you can use it if they give you the verbal description of it in words of the parabola, how I can put it in vertex form, and then how I can actually graph it from there too. So make sure you have vertex form written down. And vertex form is just being able to understand what happens with A, H, and K. If A is positive, it opens up. If it's negative, it opens down. It's a reflection. If A is greater than 1, then it's a stretch, so it stretches it out vertically, and if it stretches vertically, it actually compresses it horizontally. And if A is between 0 and 1, then it compresses it vertically, which is actually a horizontal stretch. H indicates whether it moves left or right, so it's a horizontal translation. If H is positive, it moves to the right. If H is negative, it moves to the left. K is our vertical translation. So K is positive, it moves up. K is negative, it moves down. Now, the vertex then is the point HK. Does not matter what the value of A is, the vertex is always going to be the point HK. So here we're going to use this description, write a function in vertex form, and then we're actually going to do a quick graph of it too. I'm going to have to make a little bit of room for my graph. So I'll show you how easy it is to do a graph then when it's in vertex form. Okay, so we want to take the parent function x squared. It's vertically compressed by a factor of 1/3, translated 2 units to the right, and 4 units down. So we've got 3 things happening. All right, so so we have a vertical compression by a factor of 1/3. Translation 2 units to the right, so that's horizontal, right? And then 4 units down. So we have these 3 letters we're working with. A, H, and K. So the first thing I want to do is I want to determine the values of A, H, and K. So then all I have to do is plug them in. So in this case, so always A talks about the vertical stretch, or what happens vertically as far as stretching, compressing, or reflecting. H talks about any horizontal movement, okay, left or right. And K is our vertical movement or translation, up or down. So what's the value of A in this case? Okay, 1/3, because it says it's vertically compressed by 1/3. So A is 1/3. H says it's translated 2 units to the right. So H is going to be positive 2. What if it said to the left? Okay, then it would be negative 2. And 4 units down would be K is negative 4. So we would have that G of X is equal to 1/3 my value of a, x minus 2 my value of h, and then minus k. Okay. So if h is positive, it says minus in the parentheses. If h is negative, it says plus inside the parentheses. So first thing, if I'm going to graph this, if I'm going to graph it, my vertex is now at the point 2, -4. So the first thing I would do is put my vertex in. Oops. 2, -4. Here's the vertex. Okay. Is this going to open up or open down? Okay. And how do I know it's opening up? Okay. Because what? Okay, there's no negative. Okay, a is positive, so it's going to open up. Okay, so let's see if I can actually, get my work right. I don't think this will work, but I'm going to try it. Oh, look at that. So my graph should look like this. Okay. Now, I want to explain to you how I know it's going to look like that anyways. Okay. Remember, let's go back to, let's look at our table again. All right. -2, well, let's just, yeah, -2, -1, 0, 1, and 2. Right? If we're dealing with x squared, then it's 4, 1, 0, 1, and 4, right? Okay. So if a was 1, okay, that means then that from the vertex, it would go over 1 and up 1, over 2 and up 4. Okay. And same to the left. To the left 1, up 1, to the left 2, and up 4. But since a is 1/3, I'm taking all of these numbers here, and I'm going to multiply them by 1/3. So if I go over 1, I'm only going to go up 1/3. Okay, both directions. If I go over 2, okay, then instead of going up 4, I'm going to go up 1 1/3, or 4/3, okay, which is here and here. Okay, so when I use these numbers here for x squared, I'm actually using them from the vertex. So I'm taking the vertex and going over 1 or going over 2 or over 3, whatever you want to use. So our function we would have, okay, g of x equals 1/3 times the quantity x minus 2 squared minus 4. And we check the graph. Okay, it went over 2 and down -4, so the vertex is at 2, -4. And then when it goes up, it only doesn't go up as fast. It's compressed. All right, let's look at another one. All right, what was it? Somebody asked about number 14, right? Okay, so let's look at number, well, yeah, let's look at number 14 from your assignment. We'll use that one instead. Okay, so we're taking the parent function x squared, says it's vertically stretched by a factor of 2 and translated 3 units to the left. So we're using our vertex form. All right, always a times quantity x minus h squared plus k. And I need to identify a, h, and k. So look at the things that are happening. All right, so we've got vertical stretch by a factor of 2 and translated 3 units to the left. All right, so there's only 2 things in this case. So what's the value of A then? Okay, it's vertically stretched by a factor of 2, so A is positive 2. And then it says translated 3 units to the left. Is that H or K? Okay, it's H. Is it positive or negative? Okay, so H is a negative 3. Okay, does it say anything about vertical changes? So what's the value of K then? 0. All right, good. So G of X is equal to 2 times X plus 3 at quantity squared. So if I wanted to graph this, my vertex now is at the point negative 3, 0. So I want you to do letter B on the check it out. Okay, we have one more example for this lesson. Scientific application. So, on Earth, the distance d in meters that a dropped object falls in t seconds is approximated by d of t equals 4.9 t squared. Okay, that's gravity. All right. Okay, if you're working with feet, it's 16, but in meters it's 4.9. On the moon, the corresponding function is d sub m of t equals 0.8 t squared. What kind of transformation describes this change from 4.9 t squared, and what does the transformation mean? Okay. So first thing with this problem, I want to write both of these in vertex form. Okay. So I have that 4.9 and I have that 0.8. What letters do those represent in vertex form? A, H, or K? Is that the horizontal movement, vertical movement, or stretching and compressing? Matt already said it. Okay. All right. The value of A, because where's it at? 4.9 t squared, 0.8 t squared. So we went back over here the other day, said, okay, if I have a variable, a number right in front of x squared or t squared or whatever it is squared, that's our value of A, the stretch or compression. So if I write these in vertex form, then they're going to look like this. Okay. Because the value of H and K is 0. They hasn't been moved left or right or up or down. Now the reason we're writing it out like this, because we're actually going to look at other ones in your homework. You're going to have some where H might be different or K might be different. Okay? So we want to look at it in vertex form to start with, so I can see which thing is changing. So what kind of transformation describes this change? All right. So we need to figure out what change is it. If I change from 4.9 to 0.8 t squared, is that going to be, it's vertical, okay, because we're using A. So is it a vertical stretch, or would be a vertical compression? If I'm going from 4.9 to 0.8, it's going to be a compression, right? Okay. So we have a vertical compression. But how much would this vertical compression be? Okay, Matt says 4.1. How do you get 4.1? You subtract them. Okay, is that okay to subtract them in this case? What are we doing with the numbers 4.9 and 0.8? Those numbers are, we're multiplying by those numbers, right? To be able to find something. So if I'm multiplying to be able to get something, if I'm talking about a comparison of those numbers, then I have to do what to compare those numbers? I have to divide to compare them. And so my vertical compression is going to be the smaller number over the larger number, that ratio. Okay? If it was a vertical change as far as the shift, okay, is concerned, then I would subtract to find them. I'd say, okay, it's a vertical translation up 4.1 or down 4.1. But because we're multiplying then, we have to find the ratio of those values. And what do I get when I divide 0.8 by 4.9? Okay, what is it? 0.163. Okay, so we'll say this is an approximately a vertical compression of 0.16. Okay, so our values, so what does that transformation mean then as far as talking about the Earth and the Moon? Because gravity's less? Okay. So, but here we're talking about dropping in an object, right? We're not talking about jumping. Okay. We know that if I go to the moon and because of the less gravity, that what actually happens? You're lighter. Okay. And when you're lighter, then you float, but do you fall as fast or do you fall faster? Objects fall the same. Well, says the distance in meters that a dropped object falls is 4.9 t squared on Earth and 0.8 t squared on the moon. So does that mean the object's going to fall faster or slower? Okay. So this vertical compression of 0.16 means that objects, what does that transformation mean? It means the objects on the moon are going to fall 0.16 of the distance that objects on the Earth are going to fall. Okay? So on the moon, they're going to fall at a slower rate.